to where you could wear that t-shirt alone. Not just at your fingertips and below your fingertips. It needs to be long enough to wear alone if you're going to wear those leggings. And also, not dress code related, but attendance makeup will be posted when we return. Last one is this time, please release all Air Force JROTC cadets participating in today's flight competition to the ROTC room. All other cadets are reminded to report to the library during their ROTC period if you are not participating in the flight competition. Thanks. I apologize for the interruption.
All right. So what I was saying was you're lucky because starting next year, they're putting in more requirements in the series section. And I have to teach an additional test, and then I have to teach absolute and conditional convergence. So be happy. You don't have to learn that.
So I'm going to miss out on what I would have learned if I was
Yeah.
Well, you can come back for those days. Okay, so the ratio test for convergence and divergence is the last test that we will learn. Okay? So here's the ratio test, and it actually makes good sense. So hopefully you have a good grasp on everything else and on the other ones, and it should fall in the line for you. Okay, so here's what the ratio test says. Let the series from 1 equals n to infinity of a sub n be a series of non-zero terms Mine either. My handwriting is just awful.
I can't even draw an infinity.
Okay, and here's what we can say. That series converges if the limit as n approaches infinity of the absolute value of a sub n plus 1 over a sub n. So I have just created a ratio of what? The terms, right? The next term over the previous term is how Talon phrased it. Okay? So what do you know? What is this set up like? What does this remind you of? Kind of, except for it's not two separate term generators. What have I created with those terms? I've created a what? Okay, a ratio. What's another word for a ratio?
A fraction.
A fraction, right? I've created a fraction. Okay? What do you know? What's another fraction-looking series we've talked about? Geometric, right? We have talked about geometric. If that fraction is less than 1, what do you know it does? It converges. So that's exactly what I'm taking the next term in a series, putting it over the previous term, and if that ratio is less than 1, then that series is going to converge.
So
It is so smart, isn't it?
the n plus 1 on the top of the fraction.
Yes.
Is that all like sub a?
It is a sub n plus 1, right? It is not a sub n and then a big plus 1. That's all the subscript. And that's going to diverge if what? That same ratio, a sub n plus 1 over a sub n, is greater than 1. The ratio test is inconclusive if the limit as n approaches infinity of a sub n plus 1 over a sub n equals 1.
It's not increasing, that's that.
Say that again.
It's not increasing? Or doing the function? Right, if the ratio is 1.
Yeah.
Okay. That's
Oh, that's your question. I'm sorry, I didn't know which part of this you were asking about.
the last one.
Okay, and say what you said again, now that I know what we're talking
the
about.
function's, like nothing's happening, it's just the same.
Yeah,
It's not increasing.
exactly. So there, yeah, you can't tell anything.
Okay.
Sorry, Ryan.
It's alright. I always think we doubt myself. It's like, I'm done, never mind.
No, you're not. You're really not. Yes, James?
Would it be possible to do like a sub n plus 3 or 4 if the next term
If
doesn't give
it-
you anything, like if there's no change?
No, it has to be the next term.
Okay.
Okay, so does the series converge or diverge? Let's do several examples. Now, what did we say the ratio test works well for? What type of functions?
Factorials and exponentials.
Factorials and exponentials.
I feel like we're all ahead of schedule. For our class at least.
You were doing good. Okay, so if you look at that particular series, it is both exponential and has an exponential and has a factorial in it, right? Well, we just so happen to have just learned the ratio test, which says it goes with both of those. So what are we going to do?
Limit.
We're going to set up a limit as n goes to infinity. And in place of every n, we're going to put a what? We're going to put an n plus 1, right? Because that's what we've just said here is if we set this ratio up a sub n plus 1 over a sub n, that's what we're going to be looking at. So I'm going to make this 2 to the n plus 1 over n plus 1 factorial all over 2 to the n over n factorial, right? So this is representing, the numerator of that is representing the a sub n plus 1, and the denominator is your a sub n. And then from here on out, you'll probably skip this step and you'll go right to multiplying by the reciprocal, right? Just to cut down on the work. So I'm going to have limit as n approaches infinity, 2 to the n plus 1 over n plus 1 factorial times n factorial over 2 to the n. Okay, and you're going to have to do some algebraic manipulations in this to see what happens. Okay, so with the 2 to the n plus 1 over 2 to the n, what's going to happen there? How many are you going to have left and where are they going to be left? 1 in the numerator, right? There will be a 2 left in the numerator. Okay, now what about this stuff? We've been talking about it a little bit.
It would just be n plus 1 on the bottom.
It will just be an n plus 1 left on the bottom. Why is that?
Because n plus 1 is n factorial.
Right, remember that whole decreasing thing that we wrote? Okay, so that's an n plus 1 and that's an n factorial, right? Because they decrease every term. So then what happens to the n factorials? They cancel out, right? And the only thing that's left is a what? An n plus 1 on the bottom. So what does this limit equal as n goes toward infinity? That equals 0, which is less than 1, therefore converges by the ratio test. I like the ratio test. Okay, here's 2 more to try at your table and then we're done. I know it's hard to believe. I won't still be talking when the bell rings.
When does the bell ring?
Shelby, come on. Give me the benefit of the doubt.
I believe in you guys.
Okay, there's that one.
Don't ask questions, James. I feel like it's always you. It's always you that starts the
No,
conversation.
it's.
It's okay. It's not full table. We can vote you off that.
All right, there you go. Try those two problems.
Don't be a bully. What do you do if it's already +1? Can you just do +2?
You do. You just add another one.
Yeah.
No, it's N plus 1 squared.
So that is.
When it's N plus 1, you add another one.
So it will become n plus
Fine policy.
You said
Really hard.
N cubed, it's N plus 1 squared.
Squared and then times
Everywhere
three
there's
and
an
then
n,
plus
it's going to be an n plus 1. So that's going to be
You said cubed.
Oh yeah, use that too.
What's that?
Place that in.
Sure, that's a bit. N raised to the what? Okay, there we go. You said cubed. Yes, you did.
Dude, what's your
You did. Or me.
And then
You
place
did.
of that in.
When I was there, you know what was there.
That's they were there.
All the time.
We're saying that you're like, I need to get rid of
Does it go to N plus 1?
and what you're gonna, yes.
Why would it be?
I think I
It's because like
Such a small. Why do you have it so
That's what it means. Yeah, but then this one, since there's one extra, just after this starts
How are you replacing it?
then this would be like 3 to the power of 6. So it
And at 3 something.
would be like, let's say like that extra one,
Why would you?
3 to the power 5, right? So 3, so it'd be like, plus 1 is 5, right? So it'd be 3 to the power 5, right?
Biology.
Yeah.
So it'd be 3 plus 3 plus
I'm so scared, Jenna.
All right, so here we go. So we've got limit as n approaches infinity.
I didn't finish it.
Everywhere there's an n, I'm inserting an n plus 1, right? So in place of that n, I put an n plus 1. In place of that n, I put an n plus 1. So the whole thing turns to n plus 1, which is n plus 2, over 2 to the n plus 1. And then I would be dividing by this entire thing, which is the same as multiplying by the reciprocal. Okay, so now let's do some simplifying. Let's start with the 2's. What's going to be left and where? So it will be a 2 in the denominator. Okay, so we're done with those. What about the 3's?
There will be a 3 left on top.
There will be a 3 left in the top. Okay. And then, can I do anything with these? No, I can't do any sort of canceling out with that. So I'm going to have an n plus 1 squared here, and I'm going to have an n squared here. So if you needed to like expand this binomial, I guess you could, or you can think through it. What's the highest degree term on this going to be? An n squared, and that 3 would be distributed to it. So it's as if you're talking about 3n squared. Right, so this is like 3n squared over 2n squared is what you're really approaching. So as n goes toward infinity, what do you get? 3 halves. That's greater than 1. Therefore, this thing diverges. Did you follow that, Trey? Okay. Yeah, diverges by the ratio test.
No, we have an estimator. We might do that.
Oh, biology makes me so
All right, you ready to do this one? Okay, so in place of that n, I'm supposed to put an n plus 1. So what's this term going to turn to? N plus 2 factorial divided by
3n plus 1.
3 to the n plus 1 times 3 to the n over n plus 1 factorial. I see some canceling. What do we need to do here? Right, so this would be n plus 2. If I'm going down by terms, then this is n plus 1. But I see it matches up here, so I can go ahead and just stop there and make it n plus 1 factorial. Okay, so these are going to cancel. I'm going to be left with an n plus 2 in the top. And what about these? I'll have a 3 in the bottom. So the limit as n goes to infinity is infinity. So this does what? Infinity is obviously greater than 1. So we're going to diverge by ratio test. Yes.
Is like the factorial, is that like a rapidly changing function? Because every problem that we've had where if it was in the denominator, it would always converge, and if it was in the numerator, it would always diverge.
Yeah, it's very fast. As n approaches infinity, it's huge. Because, I mean, if you think about, like, at 1,000, I mean, that's 1,000 times 999 times 998. Yes, it's a very, very fast-growing function. Okay, yes?
So if we are given a problem, would the ratio test be one of the last ones we think about using, or we recognize?
If you recognize, like you look at it and you see factorials and exponentials, that's exactly where I would go there first. Mm-hmm. Yes? Yes. Okay, what time do we get out of here today?
1, 2, 3.
Yeah,
Never right.
but
It
wait,
starts
here, I
with a
need
3.
to turn you.
It really is 11:05, you know, for starting?
Yes.
Okay.
He's gotta go pick up his first shit.
Is right.
Chicken. Oh, shoot.
That? You want that?
No, we
Okay,
got it down
I'm
more.
gonna give you guys,
I know problem.
What is that shoe? I love.
okay, so this, I'm gonna give you 9.6, which is what we just did, okay, for your homework. I'm also going to give you this in case you want it over break, and it is 14 mixed problems. It is, in theory, what you would be working on Monday when we get back, when we're reviewing all of this stuff, okay? It does have answers on the back. It asks you to use the 10 tests at least once. If you use a different test, it's okay, but you can kind of see from the back how else you could see that problem. You're also going to get this blue sheet of paper that summarizes all of the tests for convergence for you, okay, so that you have them in one place. and you can see those, okay? So Trey, here's this for you, and let me actually give you the 9-6 homework.
Yeah.
And then post it on Instagram and have friends put together so we can pick it all up and put you in this round.
Okay, so homework 9.6, that worksheet will be 13 through 29 odd and 51 through 65 odd, and it actually says it at the top of the paper.
It's face up, we're good.
No, because the back just couldn't crank.
Here's all the back.